Welcome to the ENLIGHT Lecture Series. This semester, our lectures will focus on the digital revolution and the impact of digitalization. In today's lecture, we will explore AI and its impact on teaching and learning. 3 expert speakers from ENLIGHT universities will share insights from their research in 3 short talks, followed by a discussion. Please note that the audience has no possibility to turn on their microphones or cameras, but you are welcome to post your questions in the chat, and we will address them during the discussion. By the way, the introduction you just heard was written with the support of the ChatGPT. Let me introduce our first guest, Igor Farkaš from Comenius University in Bratislava. Igor is a professor at the Center of Cognitive Science and a senior researcher at the Cognition and Neurocomputation Group. His research interests vary across the interrelated areas of cognitive science, artificial intelligence, and robotics. Today, he will talk about ChatGPT in the context of cognitive science. We are excited to hear from you, Igor.
Okay, hello. Thank you for introducing me. And I'm pleased to be the speaker in this lecture series, focusing on AI and digitalization. And since we all know that ChatGPT is a very hot phenomenon these days, I would like to introduce it, explain it briefly in the context of AI and cognitive science. So what is ChatGPT? We all know that it's a conversational chatbot developed by OpenAI, and it has been built on so-called large language models like GPT 3.5 and GPT 4. And these GPTs are basically a generative pre-trained transformers, in other words, large neural networks that can be used for various tasks. And for the purpose of conversations, ChatGPT was trained or fine-tuned using advanced machine learning techniques, such as supervised learning, in order to learn the structure of language in statistical sense, and also reinforcement learning methods that take advantage of human assistance in order to improve the performance of the generated text. The interesting thing is that due to its properties, ChatGPT does not differentiate between telling the truth and hallucinating, since it can generate text that may have nothing to do with reality. As such, it's a very versatile tool, allows easy access, and it's hence very attractive for humans who find it useful for various purposes. The statistics speaks for itself, 100 million users early this year. So we can expect that it will have a very high impact on teaching and learning, but that's not what I'm going to talk about. Instead, I will provide the context of cognitive science and AI from its beginning. So if we look into the literature, we can look at an intelligent system that could be the one that, as a first option, acts humanly. So this is something that can be tested by a well-known Turing test, where the judge, C, is communicating via terminal with 2 entities, A and B, of which both try to persuade the examiner, C, that they are the human. So if the computer can convince the examiner that it's a human, then we can say that the intelligent system has passed the Turing test. It's difficult to analyze this approach, but we know that even today, ChatGPT can be looked at from this perspective. The alternative is thinking humanly, whether the intelligent system thinks humanly. So we are trying to look inside the system. And this is something that was brought in by the cognitive science approach that replaced behaviorism in order to try to understand the internal processes that are going on in human mind. But again, this is an approach that in general is difficult to apply. The third option is looking at an intelligent system as acting, but not with respect to a human, but rationally. In other words, whether it's doing the right thing. So the system would be trying to maximize long-term reward And the good thing is that rationality can be measured if we can define the cost function. And the fourth option, thinking rationally. So we are again looking inside the system, but trying to see whether it thinks rationally, whether it's following the laws of thought, the rules of logic. But we know that not all intelligent behavior is mediated by logical deliberation. So these are the four options for definition. And in the context of ChatGPT, we are looking at it whether it's acting humanly. An intelligent agent can be seen as an entity that interacts with an environment via the percepts and acts on it via the actions. Abstractly, it's a kind of potentially complex function or mapping from percept histories to actions. For any given class of environments or tasks, we seek an agent with the optimal performance. And when it comes to ChatGPT, well, it is a disembodied agent because it doesn't have body, yet it can act, but verbally, by producing text. If we look into the history of AI, we can see that it started sometimes in the middle of the past century. And at the beginning, symbolic AI dominated the field based on rules and inferences from these rules. But later, gradually the dominance was taken over by subsymbolic AI machine learning methods, in particular deep learning. So now we can see that deep learning is part of machine learning, which in turn is part of artificial intelligence. More concretely, the symbolic AI methods in the past were focusing on knowledge representation techniques, reasoning, planning, problem solving, etc. And if we move 50 years ahead of time, now we see that much of the work is being done in deep learning or machine learning techniques. Nevertheless, we're still mostly focusing on concrete, specific tasks like image recognition, natural language processing, game playing, etc. So we talk about narrow AI, and we see that many models are very successful, often reaching human performance, sometimes even exceeding it. Still, it's, as I said, narrow AI that, honestly speaking, lacks common sense. So it doesn't have deep understanding, and also it has limited generalization ability. Well, we don't know what the future will bring, but some experts over talk about cognitive AI, which can come in hybrid form, or artificial general intelligence and superintelligence. So when it comes to ChatGPT in this context, we can say that it is that's an imitation of artificial general intelligence that's constrained to language. Right. The title says the context of cognitive science. So in the first place, what is this field? Well, it was born roughly at the same time as artificial intelligence in the middle of the past century, and it has been built on the pillars of 6 disciplines shown in this hexagon. So all that presents an interdisciplinary effort trying to understand human mind. So what are the mental representations and cognitive processes standing behind tasks or abilities like perceiving, attending to something, decision-making, acting, planning, and others? Well, how can cognitive science inspire artificial intelligence? If we look into the literature of cognitive science, there have been several modeling frameworks devised and used. The first one is Symbolic, that I already explained. The second one that came later is a connectionist, that's based on widely distributed knowledge representation in terms of neurons and connections. The third one, dynamic inactive, that looks at the human in the context, or looks at an agent in the context of an environment that's formed together a certain system. And last but not least, probabilistic models that can capture the essence of uncertainty by using probabilistic concepts. When we compare the two dominating areas or frameworks, symbolic and connectionist, we can see how they both can explain and represent knowledge when, for instance, deciding whether an image is showing an apple. So we see that the symbolic system is very transparent and well understandable, as opposed to a connectionist system that's based on numbers, making it much less transparent. So they use different processes at algorithmic level and different types of representations. Rules of logic on one hand, as opposed to algebra or numbers on the other hand. When we think of language, so in order to create word meanings that are the basic blocks, so distributional theories, they come up with representations based on distributed numerical vectors that are derived from word concurrencies in different contexts, and these are then projected in a low-dimensional latent space. So what we can observe that words with similar meanings, like doctor and nurse, tend to occur in similar contexts, and therefore they acquire similar meaning representations. So for instance, in this table, we can see that several words, like crew, oil, could be described in terms of numbers that are then processed in certain ways, that are derived from word concurrencies. And we can talk about these word representations as word embeddings that are, however, ungrounded, which is what I will explain. And on the other hand, an interesting property of these word representations, distributed representations, is that they share mutual similarity. So, for instance, the relationship of man towards woman is the same or analogical as king to a queen in this latent space. But since these word representations are ungrounded, they are derived from one another within a closed linguistic system. They are subject to Chinese room problem, which is the argument that saying that if somebody processes symbols in certain syntactic way, that does not yield understanding. And this Chinese room argument, formulated in 1980, led to the formulation of another argument of problem called symbol grounding problem, which means how to ground those meanings in the world. So when we look at humans, we know that our mind and brain contains two major systems, linguistic and conceptual system. So if you look at this picture, we see that the human agent contains both of these systems in her mind, and it also interacts with the environment that provides some reference, tokens or instances, and somehow we have to create internal representations in our mind that can have both linguistic and conceptual nature. So for instance, an object, dog in a world, can be linked with a concept in our mind that can be given a name, like symbol dog. And this triangle is known to be the basics of semiotic theory of how meanings can be represented. So in our own work, we looked at these phenomena. It was 20 years ago when we, in this case, tried to model this language learning, early language learning, in a system that was composed of two maps, two neural networks, phonological and semantic, and they were supposed to be connected with one another. So for instance, the sound duck could be processed and represented in the linguistic system, and is supposed to be connected with a meaning of duck. So in that regard, one can model the comprehension process, which goes from phonology to semantics, and production process, going from conceptual representation to the utterance. When trying to play with or study the word meanings, how the meanings should be represented. So one option is to use feature-based representations that are grounded in the world, as opposed to distributional word representations that are derived from the context. And interestingly, when the two of them were combined in a sort of joint representations, that option turned out to be the best solution. And that pretty much reflects how humans acquire the meanings of words, both from grounded features and from distributions of words in the text. So when we go back to ChatGPT in the context of cognitive science, so we can say that ChatGPT has something to do with symbolic framework because it's trained on words and corpora, which are words, which are actually symbols, but it is also related to connectionism because it uses huge neural networks to learn the relationships between these words. And last but not least, it also has something to do with probabilistic framework because it also computes probabilities and likely continuations of predictions. What's missing is this dynamic inactive part. In other words, something that could be related to grounding. Well, the progress in ChatGPT has been continuing at a very fast rate. So rather than only using classical ChatGPT now, experts are already playing with an idea how robotics could be enhanced. So as opposed to classical approach shown on the left, where the experimenter user can interact and design the robot by programming it and asking it to do some interesting things. On the right, we can have the user on the loop, which would allow the robot to interact with a human in a natural language, such as inspect the shelves in the lawnmower pattern, so that the robot would be able to solve the task when given the linguistic instruction. But in order to do so, it would have to have understanding of those words, those texts, this knowledge would have to be grounded in the world surrounding the robot, like the toys and objects, etc. So we can say that ChatGPT, since its birth, has gone already through certain stages. So it's been going through capturing cross-modal associations or correlations on one hand, when we are trying to when we are training the model by linking the words or text with images, for instance, but also with videos. So it's cross-modal associations, but going towards learning causal relationships, which is another step further towards true understanding, when the knowledge can be sort of become embodied via interaction with the environment. So to summarize, we can say that ChatGPT is an intelligent conversational AI tool that has passed Turing tests, because many people have the impression that there is intelligence behind it. It offers very wide usability thanks to easy access through the terminal. It works thanks to availability of huge training data sets, high computing power, and advanced machine learning techniques that are based on deep neural networks. It is the most influential AI achievement so far. ChatGPT represents general AI that's constrained to NLP modality, I would say. But it strongly differs from human intelligence, but after modifications, it seems to have the potential to approach the simple grounding problem. Inspiration from cognitive science may be useful along the way, even though the ultimate product may not be limited by human constraints. Last but not least, the improvements of ChatGPT are likely to be fast. Thank you.
Thank you, Igor, for this wonderful introduction. Today's second guest, Martin Takáč, is also from Comenius University in Bratislava and Associate Professor at the Center of Cognitive Science and a Senior Member of the Cognition and Neurocomputation. His focus lies within cognitive science, where he can combine his background in computer science and psychology. In his talk, Martin will explore the impacts of ChatGPT on education and society. Martin, you have the floor.
Can you hear me?
Yes, thank you.
Okay, thank you very much for inviting me to this talk. So I will try to complement what Igor said, and I will be going more into impact of ChatGPT on teaching, learning, and the society in general. So just a few terms. Large language models are these types of AI algorithms, mostly big neural networks that use large data sets to work with text, but we can have other types of generative AI, like generating images, like DALL-E, Midjourney, Stable Diffusion, or even programs for generating video, like Deep Dream, or all kinds of deepfake. And sometimes all these models are called foundation models. But I will mostly focus today on systems based on GPT, which is Generative Pre-trained Transformer, which Igor already introduced. The version that was specially tailored for chatting was released in November last year. And in March this year, the underlying neural network was substituted with a much improved version called GPT-4. But in this talk, I will freely interchange those two. So at the core of it is a large neural network that is trained to statistically understand language, which means predicting or computing what is the most likely next sentence following the previous sentences in some context. But it was fine-tuned not only for the most likely sentence, but also most relevant sentence in terms of context in which the user asks something or gives ChatGPT a task. Initially, ChatGPT was good, but not terribly good. But since it was changing to GPT-4, there was massive improvement. And this graph that I'm showing now is showing the results of it being tested on all kinds of high school or university exams, be it history, psychology, art history, chemistry, law, and etc. And you can see, especially on the green bars, which is GPT-4, that in some of these tasks, it already exceeded or reached human performance and can be close to 100%. So this program can be used for language translation, any conversation or written content generation, question answering, live dialogue, text summarization, even code generation for programming languages. And it's being used in areas like education. For example, Duolingo is now powered by GPT-4, but there are other areas, medicine, programming, as I said, law, robotics, and also defense or military areas. The company called Palantir already has an application of GPT-4 for planning military strategies. Not everybody is happy with where this is going. And in March 22nd, there was an open letter by Future of Life Institute with people like Elon Musk, Steve Wozniak, and others who raised their concerns that rather than investing all the resources into building ever more powerful and bigger models, we should redirect some of these resources to researching safety, security, and impact on the society of these systems. They even called for postponing or moratorium on development for half a year till these security aspects are better researched. Yuval Harari, which is a historian, he even warns that ChatGPT sort of hacked the operating system of human civilization, which is language, because we speak language, we think in language, our culture is built on language, our religions and politics is built on language. So he warns that if such a system can be used or is used for manipulating people, it will be very effective because of the medium, the language. And quite fresh news is that Geoff Hinton, who has more than 40 years career as a developer of neural networks, and he spent the last 10 years working for Google, quitted Google so that he can more freely raise his concerns. And he again speaks about flooding internet with fake content and many other risks. So these risks should be taken seriously. And some countries, for example, Italy, has already banned ChatGPT because of violations of data privacy and some other concerns. But let's get back to the class context or educational context. And ChatGPT provides many very significant opportunities because, first of all, it's a platform for asynchronous communication, which means students don't have to be all there at the class at the same time. They can work in their own time, and it's very engaging. And their assessments, exams, and all the learning or teaching can be customized and personalized, can be also gamified and made fun or interactive. And as for assistance to teachers, the grading of assessments can be semi-automated using ChatGPT. ChatGPT can also generate plans for lessons. In language learning, it can generate summaries, provide explanations, suggest improvements in styles, adapt the styles to different levels of learners, etc. It can also empower learners with disabilities, or it can, last but not least, because it has its own caveats, like, for example, the truthfulness or correctness of the answer is not guaranteed. So this also exposes the students to how AI works and what they can expect, what it is good for and what it is not. And the students in this way might learn to properly assess AI and use it. So that's another like side effect of using it in other educational contexts. But ChatGPT also comes with significant risks. Copyright issue is one issue, because ChatGPT generates its output based on its training input. And in its training set, there are texts that are literary pieces, and there can be protected by copyright. And there is no guarantee that ChatGPT will not generate excerpts from these texts when generating its outputs. Also, the question of biases and fairness. Training data can contain biases, and that's why sometimes ChatGPT can generate toxic or hateful content, even if there's a lot of effort into building safety filters that would filter out such contents. But also it can discriminate against certain groups of people, minorities, especially those for which there is not enough training data in the training set. Another danger is that learners or teachers may rely too heavily on the model, because anyone who has tried playing with ChatGPT will be impressed, or I would say amazed, by how good it is and how helpful it can be. But still, there is no guarantee that sometimes it makes trivial mistakes. It generates truthful and correct content, but in the middle of it is something that is totally made up or fabulated, or what scientists now call hallucinations. And that comes with lack of understanding and expertise. So if people don't know how the model works internally and what they can expect of it, that is also a problem. A big problem is plagiarism or academic dishonesty, because students can, of course, use ChatGPT to cheat, to generate their essays or their homeworks by the software rather than by themselves. And it's very hard to distinguish between a model and answers that are generated, which is unverified model output, and between real knowledge. Same as it is difficult to distinguish what is correct and what is not in the ChatGPT's output. There is also potential for ChatGPT or GPT-3 or 4 to be used to unfair advantage. If some students have access to it and others don't, then these students might look smarter and get better grades if it is not handled properly. And also the question of data privacy and security. If the students, while chatting with such a system, convey some personal or information that should not be public or not be used in other context, it's still unclear how systems like ChatGPT handle privacy and security. So what stance should universities or society in general take with this issue? So there is obviously a trade-off between advantages and risks. So one possible way is just restrictive way, ban it. Same as it was banned in all public schools in New York. It was basically forbidden to use it, and Los Angeles and Baltimore quickly followed. And there might be other cases, other examples where they chose this restrictive approach, but not everybody thinks like that. For example, there's an article in Scientific American by John Villasenor, who is a professor of law at UCLA School of Law. And there's a quote that you can read for yourself that basically he thinks that, or he actively suggests students to use ChatGPT in their assignments, because he doesn't think that in the future a student has to be good writer. In the future, student plus ChatGPT will be writing together. So to remain competitive throughout their careers, he believes that students need to learn how to use AI, but how to use it so that the output is of high quality. So he says that he allows to use the ChatGPT or similar tools, but the responsibility for the quality of the output and accuracy falls on the shoulders of students. Another example of such open approach could be a statement from Masaryk University in Brno in Czech Republic, where they basically say that be inquisitive, learn about what AI tools are at your disposal and how you can use them, but also be honest and acknowledge if you used such tools. So it's up to teachers whether they will allow using ChatGPT or not. But if they want to minimize its use, or they want to still promote students to use their own head, they should basically create more or use more interactive activities where they engage students in group discussions, presentations, and they also should require students to accurately cite and reference the work of others and verify it, because this is what ChatGPT is not very good at. And they can basically also create assessments that are open-ended, like asking students to come up with their own research questions. As for academic dishonesty, the best way is prevention. So they should educate students about what is plagiarism and why is it wrong. And also they should set clear guidelines how students are allowed to use generative AI tools. And this should be communicated well. And also, if they don't allow ChatGPT, maybe they should ask students to submit a written declaration that their work is their own and they did not use or haven't used large language models to generate it. And what also helps is to use iterative assessments, where students have to submit several versions on which they get the feedback before getting the final versions. If we want to detect the use of generative AI, we can still look for like patterns or irregularities in language, or we could check for sources and citations in the text or factual errors. But there are also some tools that are available, like GPT-2 output detector demo or GPT-0, that can be used to classify whether the output is human. Of course, they are not 100% correct, and then the teacher has to decide how to handle all potential false negatives and positives. I would finish my talk with a wonderful resource that is called digitextbook.com, where you can find much more resources about not just ChatGPT, but creative use, how to use it in the classroom for many other things, not just like ask students to generate something for them, but maybe let ChatGPT generate several versions of answers and then ask students to critically evaluate them or discuss in the class what are strengths and weaknesses of it. So I recommend everybody who is interested to have a look at this. And I will conclude my talk with the acknowledgement that these tools are disruptive technologies. They have big potential to cause changes in the society, but rather than banning them, it's good to invest into strategy, how to use them creatively and beneficially. And that's the end of my talk. And with that, I thank you for your attention.
Thank you, Martin. It was extremely informative, and I think thankful for our teaching staff, but also for the students. Our third guest, Hedderik van Rijn from the University of Groningen, is a professor at the Department of Experimental Psychology. Hedderik is an expert in cognitive science and neuroscience and is interested in bringing lab science to the real world. Today, he will share insights on how AI is being used to reduce the number of exams and improve study efficiency. You may begin your presentation, Hedderik.
Thank you so much. So thank you for this very nice introduction. And indeed, in this talk, I'll be talking about how we can use AI to reduce the number of exams and also improve study efficiency. I will take a very different perspective than the ChatGPT presentations that we just heard, because I will be looking at AI from a much more cognitive psychology perspective. In the very first set of slides, I will just be focusing on one aspect. How can we use AI? How can we use artificial intelligence inspired by how the human brain works to improve study efficiency? And when I talk about study efficiency, I'm actually only talking about a very minor part of studying. It's a small thing, but that thing, I think we can make a difference. It's about fact learning, the learning of a foreign vocabulary, but maybe also the learning of glossary items for a university course. And this is not because I think that fact learning is so important per se, but if we optimize fact learning, more time remains for studying interesting materials. Now, the two basic principles that are involved in fact learning, in any type of learning, is the spacing effect. If you spread items, if you spread study moments longer from each other, the retention is better. And the testing effect. If you're able to retrieve an item instead of just read it over, the retention is also better. Now, that means that if we want to optimize learning, the question becomes, given that we have a set of items, how can we best schedule them? And if we make the problem really simple, it would be something like, let's say that we have a session, that we have a study time of 8 minutes or 20 minutes, and we have a set of 20 or 30 or 40 items. How can we optimize the studying of those items? And for that, we went to get inspiration from a computational cognitive model, an AI model that describes how the human mind works. This is ACT-R. And ACT-R consists of many different components, but I'm just going to focus on one. And out of that one, out of the declarative memory system, I'm just going to focus on this one relatively simple equation. This is an equation that describes the activation of a fact in our minds, in our brain. If I give you a new fact, for example, that I have a sister called Sophie, then at that point in time, that fact is very highly active. If you would now not be thinking about it and I would not mention it again, it would drop in activation until sometime later I say again, I have a sister called Sophie. That same fact is also going to decay in the same way, but given this summation sign, we can actually add them together. And this way, learning, long-term retention happens. If you repeat a fact often enough, it becomes more and more active. Now, what I've shown here is sort of like presenting the item every 50 seconds. That is suboptimal. Why is it suboptimal? Because there's something that's called retrieval threshold, an activation level below which items cannot be retrieved anymore, or below which there's only a 50% chance of it being retrieved. And what we know is that if we wait too long, if a fact has dropped below the retrieval threshold, it's not optimally retained. So an earlier rehearsal would be necessary. But here we could better have waited, have more spacing, and therefore a better retention at the long term. So that means that we should not have this, but that we should have something like this, incremental spacing. And this, as you can see in the lower right corner, was already described more than 120 years ago. Why aren't we not using it? Well, we're not using it because not every fact is equally difficult. Not every learner is equally capable of memorizing a particular fact. If you also have a sister called Sophie, it will be easier to memorize that I have a sister called Sophie. So that means that where this could be a normal item, this could be a slightly easier item in case you have a sister called Sophie, or that you are just a slightly better learner. And even though we can see that on the left, the difference is very small, so the optimal moment of presenting that item again in a study session is either, say, 20 or 22 seconds. That doesn't matter that much. But at the second presentation, the difference is about 20 seconds. In those 20 seconds, we could have better practiced other items. Now, how can we figure out whether an item is black or orange? Well, for that, I need to go back to this original slide and tell you that within the ACT-R environment, we do not just have an activation level, but we can also map it to the response time. So we present an item, we wait until we think it's close to the retrieval threshold, and then we can predict what the response time should be. If we then actually observe a response time that is faster, we can use sort of like these different equations that we have and figure out what the actual rate of forgetting of this particular item should have been. And if we know the rate of forgetting for this presentation, we can also figure out that we shouldn't present this item at, say, 110 seconds, but that we can actually wait until 170 seconds. Now, this continuous updating of the rate of forgetting can be done while someone is learning. Here you see an overview of 20 items in a study session and a study session of 20 minutes. And the red dots that you see now are the 1, 2, 3, 4, 5, 6, 2, 4, 6 presentations of item 1. And you can see that the rate of forgetting is relatively stable around 0.3, our base level. Another item, the item that's presented second, is slightly more difficult. So you see that the rate of forgetting is slightly higher. And we can do that for all different items that we present. Here you can see that the orange item is the most difficult one of the current set, but that there is also this very bright yellow item that's actually relatively simple and only needed a couple of repetitions until the system knew that it was retained well enough. And that way we can sort of like look at all different items. The question, of course, is, does this work in real life? Can we actually use this? And what we did is that we tested 100 pre-university students. This was back in 2008. We had them study with either a flashcard system that wasn't optimized on response times and an optimized version. And a day later, they got an unexpected test. And what we saw was that instead of about 80% correct, it was about 90% correct. So an increase of about 10 to 20%. This effect was much bigger than we expected. So we repeated that study later on. And since then, we've been repeating it many different times. And every time we find a difference in favor of a reaction time-based AI model-driven learning system over more traditional systems. So by using the same, or sort of like using the same amount of time to study, just changing the sequence in which items are presented, you can have better learning outcomes of 10 to 20%. And this doesn't just work for vocabulary, it also works for toponyms, it works for neuroanatomy, it works for glossary items. And it can very easily be used in an online interface. So we've built this into a system, and this system is rather straightforward because in a way, nothing more is needed than what you see over here. A question, and then if you get a question, you get feedback. Now there's all sorts of other information to tell you about this, but for the sake of time, I'll skip over that. But something that I truly appreciate is that this particular system, this AI-based system, is now being used by about 1 million Dutch secondary school kids to improve their learning. Now, that is sort of like part 1. And very quickly to focus on part 2, can we also use it to reduce the number of exams? And for that, it's useful to sort of like make a jump to the cognitive psychology course that I've been teaching for many years by now. And a couple of years ago, we presented this system that we've dubbed Slim Stampen, which is a Dutch alliteration of something like clever cramming. And we had our cognitive psychology students study the glossary items with the same kind of app that I showed you before. And what you can see on the left side is an overview of when students were actually studying. And the top of the bars is the moment of the exam. So you can actually see, based on the darkness of the color, that also in Groningen, students mainly study on the very last day of the exam. And as you can see with sort of like the top line, some students even continuing studying all through the night. Now, the great thing about this is that we have all this data, and we've asked students at the exam whether they would be okay for us to sort of like correlate their learning data with the scores on the exam. And a very interesting outcome is shown in this plot, because what you can see here is that on the x-axis is the days until the exam. So day 0 means the morning of the exam. And if we look at the internal parameters of the AI model, the rate of forgetting, and we see if we can correlate that with grade, we actually get a pretty good correlation. So that means that we can already predict the score of a student, the grade of a student, by just assessing how well that student was studying. And we can not only do that on the day of the exam, but we can go back to about 2 weeks. And if we have data of those participants about 2 weeks before, we can already predict their grades. It's not a perfect prediction, but it's a pretty good prediction. So we could use that, for example, to say a week before the exam, send out an email to the students to tell them that they really should step up their studying because otherwise they would fail. But it's also interesting from another perspective, because this means that we can figure out which items are actually well retained by a particular student, because this is done per student per item. And that made me think that why shouldn't we just use the learning data to assess whether someone actually knows these materials? If your parents helped you study when you were younger, or when you were a parent, you help your kids. In my case, if I help my son study his vocabulary, I know the day before the exam what kind of grade he's going to get. I know that he knows his materials well, if he studied well, or I know that this time it might sort of like be on the edge whether he passes the exam. I know that very well, actually. And I would be willing to state that someone who observes the learning can actually make a better prediction of how well someone will be doing sometime in the future than an arbitrary test that was done at a particular point in time. If just before my son had to make his test, there was some fight in the classroom, that emotion will affect his grade. And that is in a way not what we want. So why wouldn't we just sort of like use the learning data that we collect, that we observe with this cognitive inspired AI model, to actually predict what kind of grade someone will get? Or to turn it around, to just say, why do we need a grade? We just want to know that you know the item well. And that is what we have implemented in our system. What you see here is the same system that I jumped over quite quickly before. And what you can see on the top are the lesson crowns. Every time that a student knows all the items that are being presented, that student gets a lesson crown. And this is a lesson about traffic signs in German. And what you can see on the top, on the bottom in green, is that there are 20 out of 23 items that have been practiced, but are not yet mastered. But on the left side, you can see that 3 items have already been mastered. And this is what you can see in the top left after 8 minutes of practice. If we then look at this student practicing a bit more after 10 minutes, you can see that it has now mastered 11 items out of 23. And if it studies for another 2 minutes, it has mastered all these items and it has obtained this mastery crown. Now, this is based on some sort of like theoretical idea that this is how it should work. But I truly like actually testing these things in true classroom settings. We scientists have many ideas that work amazingly in the lab, but not always that well in real world. So what we did is that we asked a group of students to actually study toponyms. 55 pupils had to obtain 2 mastery credits, these crowns that I was talking about, for 4 sets of countries where they had to sort of like know the name of the country. And this was just a homework assignment. They were just told you need to study and you need to obtain 2 crowns. And that was, as far as they knew, the whole assignment. And they had to do that before a certain Thursday, or the last day would be a Thursday. And then on a Friday morning, they had an unexpected test. So that means, given that high school students probably will not be studying that much out of their own, that they've just been studying for these 2 crowns at different points in times in the past. And the proof of the pudding would now be the score on this test. Can we say that if they had obtained 2 mastery credits, that they would do as well as if they would just have studied? Now, obviously, I don't have that kind of data. But what we can do is that we can look at the average grades. The average grade for an announced test, actually the central exam of geography in the Netherlands, is a 6.6 on a 1 to 10 scale. If you study with Slim Stumpum's mastery credits, the score, like we've seen before, is a 7.5. That means that, again, in this context, we know that if people have obtained their mastery credits, that they know the materials at least as well, and probably better due to the spacing, than in other kinds of contexts. And with this, I would like to end my presentation. And what I hope to have shown you is that we can use cognitive systems-based ideas, AI tools built on cognitive systems, to improve learning and to hopefully get rid of many fact exams. Thank you for your attention.
Thank you, Hedderik, for this hand-on approach. And now that we heard from all our expert speakers, it's time to open our discussion. So if you have any question to our experts, please feel free to post them in the chat. So far, I see no questions there. But maybe let me begin. You are all researchers at the universities. What is the current impact of ChatGPT and or AI in general you can at the moment see within your institutions, like especially from students maybe?
Maybe I can start. I also teach AI ethics, so I of course asked the students like how many of them knows the system and how many of them uses them, and everybody knew it, and like half of them were using it. I did not ask specifically what they use it for, but I think students are ahead of teachers. They already know many things, and we teachers are caught by surprise, and we are trying to sort of think about it. I for example, changed the way of marking. We used to have essays, but it makes no sense to use essays at this situation. So that's my answer.
If I could chime in, I think that so we have very similar sort of like observations, of course, as Martin just described, and I think it's another argument to move away from sort of like these static, whether it's a take-it-home exam or other kind of exam, and to actually observe what students are doing. If a student knows enough about the materials to actually ask smart questions to ChatGPT, that's a good sign. I use ChatGPT for my programming things, but it's only useful because I know what kind of questions I should ask. I know there should be an operator for this kind of thing, but I just forgot the syntax. And that means that we should move away from just tests that can be fooled by ChatGPT to actually sort of like assessing our students while they're doing the thing that they should do.
I would only agree with what Martin said, that we will have to adjust to this new situation. This semester, I'm not teaching classes where essays could be written, so I'm not facing that problem, but the next semester, that will be a challenge for me as well, to adjust my style of examining students.
So we have a couple of questions. First one is, if not essay writing, etc., how do you test students in the future? Any ideas? Memorizing facts?
I don't think that we should move to just memorizing facts. Please do not do that. Even if you're using an excellent system to learn facts, it should be much more. But I'd be happy to give the floor to Igor and Martin.
Of course, it depends on the nature of the class you are teaching. I really like interactivity. So as much as I can do it, I move the assessment from the after semester to during the semester. So students have to participate in a lot of activities for which they accrue small grades, but many of them are interactive and group work and teamwork. So I observe them working in the class. So it goes along the lines that Hedderik suggested. So it's not possible in every class, but some classes are better for that than others.
Another,
and so I think that another option that is still open is that I give exams where my students need to answer essay questions, and they need to answer them in 3 hours in an exam hall without internet access. That setup is still available. That setup is not so ChatGPT is not available there. That was a problem during the Corona lockdowns, that students were at home. But in some way, we can just keep doing things like we always did it. Internet was never allowed during our exams.
I personally like online mode. I mean, face-to-face mode of examining students, which is kind of a interaction. And there I can guarantee that the students can really take advantage of their own minds, assuming that they won't be teaching by having something plugged in their ear or what. But this is really a naked way of examining students. And of course, when it's necessary to have offline component, then it's a challenge. So like I'm saying, I have not made up my mind how I will be doing that in some classes, but face-to-face component this is what I like most. Of course, this is only enabled if the classes are small, because I can imagine teachers who teach like huge classes, then face-to-face, part is not applicable. So of course, there are always some constraints in terms of students, what can be applied, which method.
Another question we have in the chat is, what precisely do you think the role of teachers should be when using ChatGPT?
I think I already suggested something at the end of my talk. So why not to engage ChatGPT as another discussion partner? So we can have a group of students presenting their arguments, and they can ask ChatGPT. ChatGPT will generate an answer, and then they can argue with it, or assess it, or provide alternative explanations. Or so it's always possible to not use it just by, ChatGPT wrote this, I take it and copy paste it, and that's my answer, but rather critically evaluate it and work with it more in the class. So I think in this way we can engage ChatGPT and make it part of the input, but there must be a critical filter in students' heads, and that's vital, because if we know that there is no guarantee about correctness, then the weight of checking the correctness is on the students.
I see no further questions in the chat, so I would say thank you for the insights you shared with us on your research, and I invite you cordially to our networking event. I'm pasting in the chat the invitation link to Zoom, so that it's easier for you to get there. Give us a couple of minutes till we open the room, and thank you once again for being part of our ENLIGHT lecture. And there will be no recording. It's everything on YouTube online. Go to the ENLIGHT YouTube channel and you will find all the lectures there. Thank you. See you in a couple of minutes.
Thank you.